Hello everyone, this is Rekha. Today I am going to explain some of the terms related to magnetism. Consider a magnet which is freely suspended in air. So it always points to north-south direction. Let us understand some of the properties related to this magnet. So the first property is magnetic lines of force always originates from North Pole and terminates towards South Pole. Coming to second property, these magnetic lines of force never intersect each other. Thirdly, when you consider two or more magnets, like poles repel each other and unlike poles attract each other. Now let us come to the actual terms. We'll start with magnetic field. So magnetic field is nothing but the space surrounded by the magnet whose effect can be felt. Next we have magnetic flux. The magnetic lines of force, we call it as magnetic flux, and it is denoted by the symbol phi, and the unit is Webers. Next term, magnetic flux density, which is denoted by B. It is nothing but flux by area, and its unit is flux is expressed in Webers and area in meter square. Next term is magnetomotive force or MMF. The magnetic flux in a circuit is due to magnetomotive force. Also, MMF is caused due to current flowing through one or more turns. That is why magnetomotive force or MMF is proportional to current. When I remove the proportionality constant, we get N into I, where N is the number of turns and I is the current. So since it is a product of number of turns and the current, usually we express the current in amperes. So that is why the unit for MMF is ampere turns. Next parameter we have magnetic field strength or magnetic field intensity or magnetizing force, and usually denoted by H. So this parameter, magnetic field strength or magnetic field intensity or magnetizing force, is the MMF per meter length of the magnetic circuit. So we express H is equal to MMF by length. So which is nothing but ampere turns Ni by L. So its units are ampere turns per meter. Next parameter we have permeability. Permeability is the ease with which the magnetic lines of force can pass through it very easily. Through it in the sense, through the material very easily. So we have two types of permeability. One is absolute permeability and relative permeability. So permeability is denoted by mu and absolute permeability is denoted by mu naught and relative permeability by mu r. Mu naught has a constant value of 4 pi into 10 to the power of minus 7 Henry per meter. So permeability is expressed in Henry per meter. Whereas mu r is the relative permeability, which is with respect to the medium you have considered. Suppose if the medium is air, then its value is 1. Next important parameter is reluctance. Like how we have resistance as the opposition for the flow of current in electric circuit, similarly, reluctance is a measure of opposition by a magnetic circuit to the flux flowing through it. And the unit of reluctance is 1 by Henry or ampere turns per Weber. Also, reluctance depends on length of the material considered divided by mu into A. So A is the area of the material you have considered and mu is the permeability of the material. So I can write it as L divided by mu naught mu r into A. Reciprocal of reluctance is called permeance. So the unit of permeance is Henry. As we relate resistance, current and voltage through Ohm's law in electrical circuit, similarly in magnetic circuit, we relate reluctance, flux and MMF through this particular equation. So reluctance is equal to MMF by flux. Like how we have Ohm's law is equal to where resistance is equal to EMF by current or voltage by current. Similarly, in magnetic circuit, reluctance is equal to MMF by flux. That is how we got the unit of reluctance as ampere turns per Weber. So these are the different terms in magnetic circuit.